Okay, we're talking about the physical properties of ionic compounds. Let's continue with the melting and boiling points. We've already discussed that ionic compounds have strong ionic bonds between the ions, which means that in case of sodium chloride, the sodium and chloride ions are very strongly bonded together, and these bonds are ionic bonds which originate due to strong intermolecular forces between the oppositely charged ions, and it gets very difficult to break these bonds, to break bonds between the sodium and chloride ions. They require a lot of energy to break down, and so that they can move freely. And this is the definition of melting, that these bonds, these forces between these two ions, they break down so that these uh, ions can move freely, and that as a liquid. Now, they require a lot of energy, large amount of energy to break these bonds. Hence, these ionic compounds have very high melting points and boiling points. Let's talk about the solubility. Ionic compounds, they're usually soluble in water because water itself is a polar liquid. So, this calcium chloride is an ionic compound and it is soluble in water. Potassium chloride is soluble in water. Magnesium chloride is soluble in water. So, usually ionic compounds are soluble in water, but they are insoluble in oils, or they are insoluble in non-polar liquids. Water is a polar liquid, which means that water has polarity as well. Water has certain charges. How is that possible? How can water dissolve ionic compounds and not and oil cannot dissolve ionic compounds? We'll have a look at it very soon. Alright, water molecules can separate positive ions from negative ions, causing them to dissolve. For example, this is NaCl as a solid. Water has a capacity to break this into Na positive ions and chloride ions. Alright, so this is the property of water, that it breaks down these ions into this ionic solid into their ions, and this is their dissolving. When they are separated, they are dissolved. Ionic compounds are insoluble in organic solvents, for example petrol, ethanol and methanol, because these organic solvents cannot break down these ionic compounds into their ions. How does water breaks them down? Let's see. If this is an ionic solid, these are the sodium ions and chloride ions. These yellow ones are the sodium ions, gray are the chloride ions. When they're dissolved in water, what happens is water breaks them down into chloride ions and sodium ions. How? This water will surround these chloride ions, and water will also surround these sodium ions by breaking them down. Why? Because water itself is a polar liquid. Water itself is a polar liquid, which means water has charges. The water H2O, it can separate itself, or it can align itself into hydrogen and hydroxide ions. Hydrogen has a partial positive charge and hydroxide has a partial negative charge. Alright, so this hydrogen can surround the negative chloride ions, and this hydroxide can surround the sodium ions. This is a brief summary of what actually happens, but for now you just need to know that water is a polar liquid, which is why it can dissolve these ionic compounds, all right, which is why it can separate these ionic compounds into their ions. And so these ions, or these ionic compounds, they are hence dissolved in water. Organic liquids do not have this capacity. Organic solvents cannot separate themselves into these cannot organic solvents cannot separate these ions into uh, ionic substances into the ions, and hence they cannot dissolve ionic substances. There is a general rule for solubility, and that is like dissolves like. For example, water is ionic. Water is a polar solvent, hence it can dissolve ionic substances. It can dissolve substances which have charges on them. And oils or organic solvents, they are non-polar, so they can dissolve the non-polar substances. Organic solvents can dissolve the substances which do not have charge on them. All right. Now let's talk about electrical conductivity. Electrolysis is the word electrolysis. It means breakdown. Lysis is used for breaking down, and electro means using electricity. So electrolysis is breaking down of some compound using electricity. We'll study the electrolysis in the coming chapters, but for now we need to know how what is the basic setup for electrolysis. It has two electrodes or two metal plates. What is an electrode? Electrode is any metal plate or any plate. It can be carbon as well, but it has to be conductor, which is connected with the battery. With the battery, the electrode which is connected to the positive terminal of the battery, this blue terminal, which is usually the longer terminal, is the positive terminal, and this electrode which is connected to the positive terminal, it is called anode, and this smaller terminal is always the negative terminal, and the electrode or the metal plate which is connected to the negative terminal, it is called cathode. Alright, and these white ones are the connecting wires, the wires which connect electrode with the battery. And here you see a bulb. This is the battery, the positive terminal and the negative terminal, and this yellow is the electrolyte. Electrolyte is a liquid which can conduct electricity. Liquid which can conduct electricity. So this is the general setup for electrolysis. If this electrolyte, if it is a conductor, then we can assume that this bulb will light up. Alright, the electrons will flow from here to here, and this is the cathode. Cathode is the negative terminal. It must attract the positive ions, let's say the sodium ions over here, and this is the cathode. And this is the anode over here. Anode is positively charged. It must attract the negative chloride ions over here. Also, chloride ions will move from here to here, and the sodium ions will move over here. Chloride ions will move over here. If this is the case, then the bulb must light up. This means that if these charges of these ions are flowing in an electrolyte, then electricity should pass and this bulb should show some light. And the bulb should light up only when the electricity is flowing or when electrolyte is a conductor. And what do we notice? That NaCl conducts electricity when it is in molten form or it is dissolved in water, because only then these ions will be mobile, and it will not conduct electricity when NaCl is solid, because these sodium and chloride ions are not mobile. They'll be fixed. They will not flow pass electricity. The charges will not flow. And in dissolved slash molten state, ions are free to flow. This flow of charges is current. That is how we define current. That current is the flow of charges, and it is only possible when NaCl, it is in molten state or it is dissolved in water. Only then the sodium ions and chloride ions are free to move. And in the solid state, NaCl ions are fixed. They do not flow, they do not pass the current, they do not move to the opposite terminals of the battery, they do not move towards the cathode anode, hence, they do not conduct any electricity. That's it for now. I'll see you next time.